Another problem here, blocks A, B, C are placed and connected by ropes of negligible mass. Both A and B weigh 25 newtons each, and the coefficient of kinetic friction between blocks A and B and the surface is 0.35. The block C descends with constant velocity. Assume massless and frictionless release. Draw the free body diagrams for each object. So take note, as I've mentioned in my previous videos, especially sa summary, is that each object, kung daghan ganing masses sa figure, each object will have naay kaugalingong free body diagram. So for this case, there are three masses. So ang tendency is that tulo pud ka free body diagram ang imong i-expect. Okay, so here, the given are the following. Your coefficient of kinetic friction, which is simply equal to 0.35. So this is the coefficient of friction between the blocks A and B and the surface. Okay, and at the same time, weight A and B, the weight of A and B is simply equal, so you'll have WA and WB is simply equal to 25 newtons. So here, we'll start with mass A. So ang tendency is that first things first, may platform or may surface, so you'd expect a normal force perpendicular to that surface, so that would be upward for this case, and we'll call this one as normal force A. Next, naay mass, so meaning to say naay weight, which is downward. Next, so it is being stated, ang pinaka-crucial diri is simply, they descend ang block C with constant velocity. So meaning to say it's moving with a constant velocity downward. So ang tendency, ang acceleration is simply equal to 0. Okay. So ang tendency, since kini move downward, so connected man ni silang tulo, so ang kini pud si block B is towards right. Okay, nakaslant man na siya. Yes, nakaslant siya. Pero, although nakaslant na siya, you'll treat it as a horizontal nga motion. So, constant velocity acceleration is equal to 0. Here po, constant ang velocity, still acceleration is equal to 0. Okay, so here, next is that naay friction, since it is in motion. So, ihang friction is simply kinetic friction. So, naman diri ang motion. So, imong friction is opposite on that one and it's parallel to the surface of contact. Tawagon na to og FKA. Okay, napay isa. And that would be your tension, the tension between ropes or between mass A and B. So, we'll call this one as tension TAB. Okay, so there are 4 forces sa mass A. So, ang tendency is that here, we're gonna label this FBD for mass A, MA. Okay, so you'll have here positive Y, and then you'll have here positive X-axis. So, ang tendency is that you'll have normal force NA, upward. Downward is your WA. Next is your friction, FKA, kinetic friction. And the other one is your tension, TAB. Okay, so again, acceleration for this case is equal to 0. Next is that for your mass B, so here, so ang pinaka-nice drawingan is your normal force perpendicular to the surface of contact. So you'll have here, we'll call this one as NB, normal force B. And basically, next is that i-extend mo na siya, dili na siya ang weight, kaya vertically downward man ang weight. So ang tendency is that you'll have your weight here, kaniya. Okay, this will be your WB. Next, napay kulang, you'll have your two tensions. This time, this will be your tension TBC. and the other one is your tension TAB. Okay, basta mo obey og Newton's third law. And the next, napay ko lang, last, ang ikalawang mga force is your friction sa mass B. So, naang motion pa right, so most likely, pa left imuhang friction. So, we'll call this one as F, kinetic friction for mass B, FKB. So, basically, here, take note, pwede ra niyo dili i-tilt, pero ako kay ganahan ako nga i-tilt. So, this is your positive Y. So, mo ni mong negative Y sa opposite. So, meaning to say, imong weight kay nasa left side sa negative Y axis. And kaning negative Y paingon sa weight, kung pilang angle of inclination, 36.9, mao po ni siya nga angle diri. 36.9 degrees. Okay, we'll transfer that one in a free body diagram. So, positive Y axis ni positive X. So, you'll have your normal force B na diri nga side. So, you'll have NB. And then your weight, wala dili vertically downward, but na sa left side sa negative y-axis, so you'll have WB. And then kini ang angle of inclination, which is 36.9 degrees. Next, you'll have tension TAB. So you'll have here tension TAB. And then your friction FKB. So you'll have FKB. And lastly, you'll have tension TBC. Okay, you'll have TBC. Again, I repeat, the acceleration for this case is equal to 0. Next, last, for mass C, you'll have here, for mass C, nalay duha ka forces nasa yaha. That would be your tension TBC. Again, I repeat, kung mag-draw ka mag-forces kinagid sa origin ang nasa center sa block or sa mass ang origin. So that is why tanang forces gawas sa body. So you'll have TBC and then your weight WC. So you'll have FBD for mass C. Okay, I forgot to put labels here. So you'll have positive Y and then you'll have positive X. So nakay tension TBC and then you'll have downward ang WC. Still, acceleration is simply equal to 0. Okay, so here is that next, mora na ilang mga free body diagrams, no? So, next yung buhaton kay evaluate ninyo ang mga vectors kung galay ba along X or Y. So, para na may idea, kinsa inyo ipang components. So, basically, si WB kay kinahanglan nimo siyang i-component method. Pero, let's proceed to letter B kung ano siyang gi-ask. For letter B, find the tension in the rope connecting blocks A and B. So pasabot, it's looking for tension connecting blocks A and B. So it's asking for pilay value sa tension TAB. Okay, so here is that. If you'll notice, let's look for the FBD of your MA. Okay, tara no. Kini siya nasa x-axis. So ang tendency is that obey ang system kay ni-obey siya Newton's first law. So ang tendency is that we're going to use the free body diagram of MA. So ang tendency is that you'll have here for mass A, you'll have summation of forces along X is simply equal to 0. Okay, first law man. 0 man acceleration. So i-add ang mga forces nasa x-axis. So basically, duha lang man kabuok. So you'll have here your TAB, which is positive, kay towards right, or towards positive x-axis, and then ang opposite kay you'll have F, kinetic friction for mass A. So duha lang man imong gi-add, and then equate that one to 0. Okay, so ang tendency is that mag-add ka both sides of FKA, or yeah, I know it's wrong na ang term kay transpose. Sige na lang. So you'll have TAB is equal to FKA. Okay, so equal ra ang tension between blocks, connecting blocks A and B, and it is equal to your kinetic friction. So, take note, ang equation sa kinetic friction kay coefficient of kinetic friction times ang normal force A. Okay, so we have a problem here. Wala tayo normal force. So, ang tendency is that lantaw ang normal force A na siya sa y-axis. So, this time is that i-add na to ang mga forces nga nasa y-axis ug i-equate na to og 0. So, ang tendency is that normal force is upward. So, duha ra gyapon ka force, no? Ang nasa ang mga vertical forces. So, you'll have here NA minus WA, which is simply equal to 0. So, you'll have here your NA is simply equal to WA, which is ang weight A is equal to 25 newtons. So, here na natay value, our coefficient of kinetic friction is simply equal to 0.35. Kung ang WB or ang weight ni mass, rather WA and WB is equal to 25 newtons. So, substitute the given values. So, you'll have 0.35 times your normal force mass A is 25 newtons. So the answer for your tension between blocks A and B is simply equal to 8.75 newtons. So you'll have 8.75 newtons. Okay. Next, for letter C, it's asking for the weight of block C. So asa daw ni equal to. Okay, so here is that we are going to use the free body diagram for mass C, kaya mo man yung ipangita, no? So, ang tendency is that here, for mass C, MC, so you'll have here, still we're going to use Newton's first law. So, summation of forces along Y is equal to 0. Wala man siya forces along X. And it is 0, acceleration is 0. Take note. Tension BC is upward, so positive, and WBC is downward, so negative. And then equate that one to 0. So take note, see tension TBC is simply equal to your weight C. Okay, so we need to find the value of your tension TBC. And then equate that one here. So next, tension TBC is naa sa free body diagram sa mass B. So here, mo na po natong gamiton for mass B. Gamit tag free body diagram niya. So, summation of forces along X is equal to 0. So, daghang forces nasa X. There are 1, 2, 3. Ikaupat ang WBX. So, we need to find the component first aning WBX. So, you'll have here downward. So, you'll have WBX. So, you'll have here WBY, and then you'll have here WBX. Okay, so it's on the adjacent side of angle 36.9. So so you'll have here your W, dire lang natin butang, no? Your WBY and WBX. So WBY lang so you'll have here weight B, WB cosine 36.9. Okay, so ang weight B is 25 cosine 36.9 is equal to 20 newtons. So that would be your WBY. Next, for your WBX, that would be 25 sine, it's on the opposite side, so 36.9 degrees. So the answer will be 15 newtons. So this will be your WBX. Okay, so here we're going to add all forces along x baliktad. So you'll have here TAB, it's towards left, so negative TAB minus FKB, and then you'll have plus TBC, and then you'll have here, don't forget this one, you'll have minus WBX, and then equate that one to 0. So you don't have any values for your, you have value for your tension TAB, right? So this is simply equal to 8.75 from letter A. So you'll have negative 8.75 newtons minus ang equation sa friction kay mu K times normal force B plus TBC minus WBX, which is equal to 15 newtons. And then equate that one to 0. So next is that you'll have here, you may substitute all the given values dari para easier lang lantawon. So you'll have 8.75 minus 0.35 times your normal force B is wala ta kabalo pila iyang value. So you'll have TBC minus 15 newtons. You can actually add this, combine these two. Okay, but then we're looking for the value of your normal force B. And i-check nyo imong normal force B is along Y. So this time you have add all forces along Y and then equate that one to 0. Okay, there are two vertical forces lang. You'll have your normal force B, positive, minus WBY kay downward. So you'll have WBY, which is simply equal to 0. Transpose this one to the other side of the equation. So your normal force B is equal to WBY, in which ang value niya is simply equal to 20 newtons. So therefore, this is simply equal to 20 newtons. Multiply this 2 here, and then combine this 8.75 and then 15. So you'll have a value for your tension TBC, which is simply equal to, your TBC is simply equal to 30.76 newtons, or approximately equal to 31 newtons. Okay, so this is not yet. Take note that TBC is simply equal to your WC. Okay, lastly, for letter D, if the rope connecting A and B were cut, what would be the acceleration of C? So for this case is that once makat na tong C, mo-accelerate ang imuhang duha ka object with the same magnitude. So nganong the same man magnitude, it is assumed nga ang pulley ug ang mass sa pulley is wala, negligible, and then even the weights of the rope or ang mass sa rope. For letter D, if the rope connecting A and B were cut, what would be the acceleration of C? So basically, if katong mass A nga nakakonect diri is naputol, so ang tendency mo-accelerate ang duha ka object of the same magnitude. Nganong same og magnitude? It's because gi-assume nga massless ang rope, and then ang pulley is massless too, and then frictionless. Okay, pero in reality, kay kung i-consider nimo ang mass sa rope and even this pulley here, so di yun na siya ma-accelerate. So for this case lang, is simply idealize lang. So massless ang pulley, frictionless ang pulley, and then even the strings. So for this case is that here, you need to consider the masses or the weights of each object kung kinsay mass bugat nila. So ang WC has 31 newtons, right? So i-check nimo kung asa mo-accelerate. And your WB has 25 newtons. Okay, so most likely mo-accelerate ang object, of course, simply downward. Okay, so AC, acceleration for that one. And kinipod is move siya towards right. So this would be your A, B. And the next is to draw a free body diagram for each of the objects. So here you'll have here your normal force B again. And then you'll have tension TBC. Lahi na po ng tension for this case. Tension TBC. And then you'll have here. So, ang nawala lang dili kay katong tension TAB. You'll have your WB, which is vertically downward. This is your negative y-axis. Ano inyong positive y-axis. And then here, nakay friction F, K, B. Okay, so ang tendency is that more na siya. So if we're going to transfer that one into a tilted nga XY z-axis, so ang tendency is that you'll have here positive, this is positive y-axis, and this is positive x-axis. Again, normal force nasa positive y-axis, normal force B. And then your WB kinadiri sa left side sa negative y-axis. And ang angle of inclination is 36.9 degrees. And then you'll have friction FKB. And then you'll have tension TBC. Okay, acceleration is towards right. A. Okay. So, pwede ra pod A lang atong ingalan nila, no? Pareha naman sila magnitude, different lang ang directions sa acceleration. Next, for mass B is that here, nasa duha ka forces though, so you'll have here tension TBC, and then you'll have here WC. So there are two forces nga nasa iya. So ang tendency is that ang free body diagram for this case here, so you'll have here positive y, and then you'll have positive x-axis. I forgot to put labels. This is the FBD for mass B. And then ang FBD for mass C. Bag-o nga FBD nila. So, acceleration is simply downward, take note. So, you'll have here tension TBC, which is upward. And then you'll have here weight WC. So, here, for this case, is that we are looking for the acceleration, mga bata. What would be the acceleration of C? And that would be equal of magnitude sa acceleration ni mass B. Okay, so first things first is that here, di na siya mo-obey og Newton's first law ang system, but rather the Newton's second law or the law of acceleration. So, pinakauna, we'll form an equation using this free body diagram. So, for mass B, we'll have here summation of forces along X. Summation of forces along X is simply equal to, okay, tanawa acceleration horizontal. So, meaning to say, ang forces horizontal is affected sa acceleration. So, this is simply equal to M, B, and then A. Okay, positive since by convention, padulong siya sa positive x-axis. So for mass B, kung maggamit kag summation of forces along Y, that is simply equal to 0. Okay? So ang acceleration is purely horizontal, so ang y-axis kay unaffected siya. So that is why this is equal to 0. Okay, so here, i-add na to ang forces nga nasa x. So if you'll notice, na kay 1, 2, and ang ikatulo kay ang W, BX. So, if you'll try to component this one again, you'll have WBY, which is simply equal to 25 cosine 36.9. So this is simply equal to 20 newtons. Ato na rin na-calculate. And then your WBX is simply equal to 15 newtons. So a tendency is that substitute that one. So you'll have here TBC positive towards right. So TBC, i-add ang mga forces ka nasa X minus FKB, and then you'll have here minus WBX, which is tulo lang man kabuok ng mga forces, equate dayon nimo og MBA. So you're not yet done. So basically, ma'am, ang tension TBC is equal to 31 newtons. Nope, mag-change na, take note. So kagay na lang to siya sa mga previous nga questions nga equal to 31 newtons ang TBC. So this time, mag-change na kay remove man ang block A. So you'll have here TBC, substitutan nato ni silang values. Ang friction kana equation nga mu K times normal force B minus 15 newtons, which is simply equal to ang mass B is simply wala may mass if you'll notice no nga gihatag. Pero take note that your weight is simply related to your mass, so this is simply equal to mass B times acceleration due to gravity G. To look for your mass, you'll have here, pwede divide G both sides of the equation. Divide G both sides of the equation. So, pwede na siya nga your mass B is simply equal to weight WB divided by acceleration due to gravity. Okay? Which is simply 25 divided by 9.8 meters per second squared. And that would be equal to 2.55 kilograms. Even for your WC, you can actually calculate for its mass C by dividing WC with 9.8 meters per second squared. So that would be equal to 3.2 kilograms. Okay, so let's move on. So ang tendency, this is simply equal to 2.55 kilograms times the acceleration A. So take note that we can actually substitute the values for your mu k, which is simply 0.35 times your normal force B. So again, your normal force B is simply equal to 20 newtons. Yun sa nako pagkabalo nga equal to 20 newtons siya. So here, summation of forces along y is equal to 0. So you'll have normal force B positive, and then you'll have minus WBY, which is equal to 0. So add WBY both sides of the equation. So ang tendency, your normal force B is equal to your WBY, which is equal to 20 newtons. Okay, so you can actually multiply here 20 newtons to 0.35, and then you have minus 15 newtons, which is equal to 2.55 kilograms times A. C, you'll have here for mass C, you'll have summation of forces along Y is simply equal to, wala may horizontal na nga forces along X, so diretso ta along Y, which is simply equal to negative MCA. Anong negative? Because by convention, padulong siya sa negative y direction. So, ang tendency that would be negative. Directions lang ng negative. So, add all forces along y. So, you'll have here TBC minus WC, which is simply equal to minus MCA. So, you don't have any values for your TBC. So, you'll have minus 31 newtons, which is equal to negative 3.2 kilograms times the acceleration a. So you have the second equation. We will call this one as equation 2. So this equation here is simply TBC minus 22 newtons, which is equal to 2.55 kilograms A. So we will call this one as equation 1. Okay, there are two unknowns, A and TBC. So we will need one more equation to solve for your acceleration A. So using these two equations, we're going to solve for A in such a way. Now we will eliminate TBC by subtracting equation 1 to equation 2. So natay TBC minus 22 newtons, which is equal to 2.55 kilogram A, and then minus TBC minus 31 newtons, which is equal to minus 3.2 kilogram A. Okay, these things here will be cancelled out, getting TBC. So you'll have here 22 plus 31, so making it 9 newtons, which is simply equal to 2 by pi minus quantity 3.2, making it 5.75 kilogram A. Divide both sides by 5.75 kilograms. 5.75 kilograms. So ang tendency or acceleration is simply equal to 1.54 meters per second squared. So take note that for mass C, the acceleration is simply equal to 1.54 meters per second squared, and its direction is simply downward. So this will be the final answers for that